I'm Rick Nelson, and on behalf of the AASHTO Committee on Maintenance, their Maintenance Operations Technical Working Group, and the Winter Weather Management Technical Service Program, formerly known as SICOP, SICOP Talks Winter Ops is proud to host this fourth National Winter Maintenance and Road Weather Briefing. Now, these briefings give organizations working in the severe weather and maintenance operations space an opportunity to showcase their efforts to help you achieve your winter maintenance and operations mission. Now, this briefing features the Maintenance Decision Support System Pooled Fund, and with us today is Dave.Huft from the South Dakota Department of Transportation and Shawn Truelson from DTN. Dave, Shawn, it's good to see you again.
Yeah, thank you, Rick.
Before we get started, Dave, could you tell us a little about yourself and how you came to be associated with the MDSS project?
Sure. Um, I'm currently the ITS program manager in the South Dakota Department of Transportation, but prior to that, I was the research program manager. And this pool fund study was initiated and run through the Office of Research, and so I became the project manager for the pool fund study. Study started way back in 2002 with 4 states, and it's still continuing now.
So, Shawn, what role does DTN play?
DTN currently serves as the lead contractor for the MDSS Pooled Fund. This happened in 2020 when we acquired the road weather area of Iteris, who was the previous road MDSS lead contractor. And I've been involved as the product manager and project manager of the program since that time. So I work closely with Dave to organize our meetings and organize our work plans and make sure that the research is moving forward.
Great, great. So Dave, what's going on with the MDSS these days?
Well, I think I'll start out, Rick, with a little background about the pool fund study. And if we can go to the next slide, very good. So the MDSS pool fund study is called Development of an Operational Maintenance Decision Support System. And it was initiated in 2002. There were 4 states, Indiana, Minnesota, North Dakota, and South Dakota, who were aware of the Federal Highway Administration's work on a maintenance decision support system prototype. And we thought it would make sense to build on that work and do something that was specific to our state needs. And since that time, 21 different states have participated in the pool fund study. South Dakota has been the lead state from the from the beginning. South Dakota has been the lead state from the beginning of the pool fund study and remains that. There are 10 active state DOT sponsors right now, and state DOTs and other agencies can participate. We've had some county involvement in the pool fund study. Um, the Each state in the pool fund study contributes $30,000 per year to jointly fund the research and development that goes on in the study. We meet 3 times per year in person. We sometimes have online meetings in addition to that. Um, and as Shawn mentioned, our lead contractor for the work is DTN. Sometimes the question is raised, well, why would you need a maintenance decision support system? And I recall in the early days, one of our maintenance managers said this to me. He said, "Do you mean to tell me a computer is going to tell us how to do winter maintenance?" And the answer was, well, yes, kind of. That's true. And so it's a legitimate question, though. Why would you do that? And one reason is that there are rising demands from travelers and commercial carriers. The amount of travel is increasing, especially on the commercial side. The demand for just-in-time delivery and reliable transportation is um, increasing all of the time. On the agency side, our costs are rising, and so we have higher labor costs, higher material costs, higher equipment and fuel costs. And it's important that we do our winter maintenance operations as efficiently as possible just because the costs are raising. And coupled with rising costs is the fact that our funding is not unlimited. We have all have constrained budgets. And again, that makes it important that our operations be as efficient as they possibly can be. Especially when the pool fund study was getting started, it was really difficult to get reliable and timely condition reports on roads. And these reports are important for at least two groups. First of all, it's important to travelers to have good information about the condition of the roads, but more to the point for maintenance decision support, it's important for our maintenance crews to have timely and reliable information on the condition of the roads. And we could say not only the current condition of the roads, but the anticipated condition of the roads as winter events progress. Some winter conditions are difficult to anticipate. We see often storms that have kind of sharp edges. On one side of the line, you'll have heavy snowfall and high winds, and maybe as near as 40 miles away, there really isn't anything going on. And so one of the objectives of MDSS is to provide as accurate information on current weather conditions and forecasted weather conditions as possible, because that's going to affect the maintenance need on the highway. Um, Winter maintenance is a complex operation. When weather happens, what happens to the roadway is complex. It depends on the temperature, it depends on winds, depends on the traffic that's on the road, it depends on the maintenance treatments that you apply and the materials you use. And the MDSS is able to analyze that more comprehensively than I might be able to analyze that in my own mind. In the time since the MDSS project got started, there have been a lot of new de-icing materials, increasing use of liquid materials, both salt brine and mag chloride and other liquid solutions that have organic materials in them. And one of the things that MDSS can do is take into consideration the specific properties of these de-icing materials and what effect they're going to have when applied to the roadway. An important concern for some of the states in the pool fund study is the environmental impact of de-icer use. And so if we're concerned about the amount of chloride going into the watershed and the effect on roadside vegetation, it's important that we try to minimize the amount of chloride that we use, and to the extent possible, limit that effect. And MDSS, by recommending the most efficient treatments, can help reduce the total exposure. And then a real important thing in the state agencies is that we have limited staff size. It's important that we make best use of the staff as possible. And we're seeing a lot of turnover through retirements and job changes, and a reduction in the long-term experienced staff that we've had traditionally. And so some of the newer maintenance workers need the guidance that an MDSS can help provide.
Right. Dave, on that experience piece, everybody that's behind the wheel in a snowplow is a decision maker, and even though you give them like this guidance, understanding how things change and evolve through the course of a storm is really important. There's a lot of information going on, and the MDSS can really help them uh, make those smart decisions as the storm progresses.
That's correct. And among the states that are in the MDSS, there are different models of management on the roadway.
Hmm.
Some agencies are pretty much driven by maintenance supervisors, and the operators do what the supervisors direct to them. And in that case, the MDSS can inform the supervisors of the best course of action. In South Dakota DOT, the individual snowplow operators have a lot of discretion. And so the information is coming directly to them and similarly informing their decisions.
Yeah. Okay.
Well, Dave was asked by many people, how can a computer tell me what to do? Well, this graphic points out the engine behind the MDSS technology that is doing exactly that. It's taking information in on weather, So atmospheric conditions such as temperature and precipitation, current as well as forecast. It's also looking at the roadway, what it is made of, what the surface is, and what is happening underneath. And it's modeling the actual energy and mass transfers of materials such as snow, ice, chemicals, and the heat that is gained and lost by the pavement. It's a very complex model that is also tuned to agency best practices, available materials, equipment, and staff, cycle times, etc. And it's looking as well at what has been done on the roadway historically. So, with all of this information, MDSS is able to model the current road conditions, model what's going to be happening in the future, and provide a treatment recommendation for that particular route that is based on the agency's best practices. So there's a lot of information going into this, and models are never 100% correct, but this is doing a good job in providing treatment recommendations that are also based on the most efficient and effective way of taking care of the roadways to meet the level of services defined by state agencies. The MDSS has also been designed to not only work within a storm system, it is designed to provide information well before a storm hits to help people get prepared before the season and to look at resources that may be needed before the winter season even starts. Certainly, before an event happens, we do have weather forecasts, and if potential events can be identified. And the MDSS allows maintenance supervisors to take a look at what is expected to happen and actually plan for that event, for scheduling, for truck positioning, for all kinds of things that they do. This information is updated throughout the event, especially to make tactical decisions as possible weather conditions change, road conditions change, etc., until the level of service that is specified is maintained. And even after an event, it's looking at blowing snow type situations or other things happening on the roadway so that all of the operations can continue to take care of providing that level of service. After the storm, there are extensive tools to analyze what happened, what went well, what didn't go well, and also provide reports to management to help management understand what was the severity of this event, how did things go, and justification for use of materials and staff throughout the event. I wanted to point out too that the MDSS tools have been adapted for summer operations as well, such as construction, striping, chip sealing, etc. So these same decision support tools have been applied to summer as well as winter maintenance operations.
Shawn, how often does the system go through an iteration and provide a recommendation?
Well, actually, it is taking information indirectly from the plows from AVL MDC systems that are telling them what is being done on the roadway, where a plow truck is, and it is taking information in from the operators that indicate road conditions and weather conditions. So every time this information is received, the model is updated.
Okay.
The treatment recommendations are produced in an ad hoc manner and delivered to the people looking at MDSS.
Okay. Okay. Very good. Thanks.
So the MDSS Pool Fund study is an ongoing research and development activity, and it's led to development and evolution of the MDSS over a period of nearly 2 decades, not 2 decades now. But an important thing is that all of the research and development that is done finds its way back into um, the refinement of the MDSS. The MDSS is used operationally in by 19 state agencies right now. So it's not just the pool fund study states that are using MDSS, but it's actually being used by nearly as many other states as are in the pool fund study right now. Our ongoing activities concentrate on enhancements and adjustments to the road weather model. We're always looking for ways to more accurately and reliably make the predictions of what the road conditions are going to become. That's really important because that influences what the maintenance recommendation uh, is, and make sure that the recommendations are appropriate to the road conditions that are in place now and are coming. Um, we have several versions of the MDSS. One web-based version is what I have on my desktop, and so that I can see all of the information. We're looking here at a screenshot of the web MDSS. You'll see a lot of information there, including a map. This is of the Minneapolis area that shows snowplows and cameras and road conditions and so forth. Also, many alert panels, links to onboard instrumentation on the trucks. In the case of MnDOT's truck here, we even have a dash-mounted camera showing the road conditions that the plow is encountering. But there are also mobile app versions that I could see information on my phone, and in-vehicle MDSS for vehicles that are equipped with tablets or mobile data collectors on board. Another thing that we have done a lot in the course of the MDSS is providing additional support for liquid materials. I mentioned earlier that there's been a transition to liquid materials. In fact, a couple of states in the MDSS are trying to move almost exclusively to use of liquid materials. And so making sure that the MDS properly models the behavior of those materials is another important activity.
The MDSS pooled fund study is currently in phase 12 of the research and development tasks. These phases are 2-year time periods where a work plan is developed and tasks are tackled by the entire group, and resulting in improvements in the MDSS technology. One of the things we studied in phase 12 is a small segment pilot. In general, MDSS was set up for typical plow routes of about 10 to 15, even up to 30 miles. And we're realizing that information may become more relevant if we break those plow routes into smaller segments so that more location specific information can be integrated and potentially more direct treatment recommendations can be provided. Now, this can get pretty complex because how small do you make these segments? But we did this pilot project to start looking at how mobile RWIS may be used within the model. And specifically friction or grip data, how could that be enhancing the MDSS ability to create road condition forecasts and better provide treatment recommendations? So that's one of the tasks that we tackled in phase 12. We also looked at enhancing tow plow support within MDSS. And this came up because as new technologies are developed, they need to be added to MDSS. Many agencies are using tow plows, but this data wasn't getting into MDSS necessarily by all of the AVL MDC data feeds. So the group tackled this project by starting with the AVL MDC data feed providers to make sure that the data was being brought into MDSS and processed. We also had to adjust the screens and the reports in MDSS so that this tow plow data could be displayed and reported properly within the system according to the way the users need to see it and to have it reported. So the results of this particular subcommittee was a document to guide any AVL MDC provider in adding tow plow data to their feeds, and then it will be utilized within MDSS by the agencies that have tow plows.
Yeah, and Shawn, I guess the thing that's important about this is that tow plows are plowing 2 lanes, right, at once, as opposed to just the single plow in the single lane, and that's important to feed that information into the MDSS.
Yes, absolutely. Without having this information come in, the material usage is incorrect. So, this is very, very important work, but it also has been noted that, especially with staffing issues, tow plows really help in making the operations more efficient. And gathering this data and putting them into reports provides justification to upper management as to how tow plows are able to help make operations more efficient.
Yeah, thanks.
Another area of work was to develop what we called the objective analysis screens for MDSS. MDSS contains a lot of information, but this work put analysis screens together in one place so that people interested could take a look at an event, all aspects of that event, what was done, and what were the results in one place. This has really helped to provide greater insight during the past winter season into some very complex scenarios, and how MDSS responded to those scenarios. It's helping us in various ways, not only to improve operations, but also to understand places within MDSS that can be improved, as well as it's a great resource for customer support as information is made available in a more direct manner to address questions and issues being reported by users. Another key piece of research is our assessment of recommendations study, and this has actually been going on since 2012. The purpose of this study was to really get an idea of, is MDSS working for operators? What do they think about it? How are these treatment recommendations being perceived by operators? And are they making sense for what is needed along the roadways to bring uh, roadways to the level of service that is needed? We again had a subcommittee focus these past 2 years, and we delved into how do we get more information from the operators. We have been doing this since 2012, but participation has been kind of falling off. So we started a trained collector program to get higher quality feedback from actual operators. We developed a screen right within the plow truck that, as you see on the right hand side, uh, gives operators a lot of information, but has added a thumbs up or a thumbs down assessment to each of the treatment recommendations being delivered to the operators right in the plow vehicle. Once the operator gives a thumbs up or thumbs down, they're brought to a second screen to provide more information as to why they think that treatment is appropriate or not. The results of this study have actually told us that in about 80% of cases, treatment recommendations are accepted by operators. And this has been fairly consistent since 2012. So that is really an interesting uh, statistic to look at. But what we're concerned about is the 20% of declines. We really can gain some valuable insight into MDSS, the way it's working, and where we can make improvements by looking at this 20% and why these declines were made. These are some of the things we found when looking at these declines. And in most cases, in fact, 60 to 80% of the cases, it was really based on the fact that MDSS didn't have the current road conditions correct. Now, this is really a hard thing to get to. A model cannot be 100%. So in 80% of the cases, maybe it was correct, but in some of these other cases, it was not. In fact, 60 to 80% of the time, operators are saying you've got the wrong road condition. So we are actually looking at this. How can we get better road conditions into MDSS? How can we make it more consistent when operators report those road conditions? How can we make it more accurate overall so that treatment recommendations will be more accurate? We've also taken a look at the weather conditions and forecast scenarios where the acceptance has been lower. And we found that frost situations, blowing snow, and rapidly changing conditions are really hard for MDSS to model sometimes. Well, that's sort of intuitive, but it's nice to see it in the statistics, and we're working as best we can to make the model better in those scenarios. We also mentioned this earlier. In the way MDSS is designed, we've got 10, 15, 30-mile segments, but along those segments, I should say routes, are differing conditions, different sheltering, different shadowing, different road conditions overall. And MDSS was designed to provide one treatment recommendation for the entire route. So we're looking at that. How can we change things to make it more location specific without overloading operators with too much information? MDSS configuration. If a route isn't configured correctly, MDSS is not going to work. When consistently a route is giving bad treatment recommendations, we often take a look at that route configuration. And when those routes are updated, sometimes very quickly, MDSS is all of a sudden working really well. So that's something we like to find and take care of right away because it's very effective. Also, too, MDSS does depend on RWIS information from spreader control systems and various other sensors. If those sensors aren't calibrated or configured correctly or are just simply not working, MDSS has a harder time with providing the correct treatment recommendations. And then always we have to look at the user perspective and interpretation of what is being provided by MDSS. And that's a very big factor. We can learn things from this analysis and apply information during training, for example, that may help with this aspect and make it more acceptable and easier to use and understand by operators.
The MDSS, excuse me, the MDSS pool fund study does work in phases. Um, in recent years, we've been defining 2-year phases of work and just identifying the specific elements of work that we're going to pursue during that 2-year period. We're just at the beginning of deciding what we're going to do in the 13th phase of work. And so we have a lot of possibilities for research and development activities. The members of the pool fund study vote on which activities to fund. And so between now and the end of July, we're going to be deciding which of these potential topics will actually be included in our next work plan and emphasized as elements of work. Some of the potential topics that we are looking at are integration of friction and grip measurements into the MDSS. The MDSS primarily models the surface of the road, and whether there's water or ice or slush or snow, and the thickness and mixture of those compositions of materials is really what is being modeled. And so a friction and grip measurement is somewhat different from that. It's an estimate of what the friction coefficient is going to be. And so there's some fundamental work needed to determine how to connect friction and grip measurements and how to associate that with what is being modeled in MDSS, and how to take advantage of the friction and grip measurements that are available both at fixed RWIS sites and at mobile RWIS systems. We're going to continue looking at focusing on liquid materials because of the importance that they are to several states in the pool fund study, and we feel like there may be a real need to characterize additional liquid materials for their melting properties and behavior properties. So that's a possible area of research. Another one is looking at the variability of conditions and application rates that exist within the snowplow routes. And one of the things that the onboard uh, instrumentation does on snowplows is keep track of the application rates that have and the location that have been applied. And so, by looking at historical records of this, it would be possible, for example, to say that certain places within a route um, typically need more treatment than the rest of the route or less. And so it would be a way to develop kind of a heat map as to uh, the variability of the maintenance demand within routes. Another thing that would be very useful for us would be to be able to derive road conditions from camera images. So we get camera images from fixed locations like RWIS sites, but we're increasingly getting camera images from onboard cameras, dash cams, and snowplows and other maintenance vehicles. It's time consuming and cumbersome to manually interpret these images, but if there's a way to use image recognition, image interpretation to infer what the road conditions are, that would be really useful for many purposes within MDSS. Another area of inquiry concerns level of service. Part of that is just how do you define level of service in a way that's meaningful for a multitude of purposes. Level of service means something to a person who might be commuting to work in the morning, and they may have an idea in their mind about what level of service means. It could mean the condition of the road. It could mean how quickly that condition is attained. But level of service can have different meanings to maintenance staff. What quality of road surface are we attempting to attain? What what is an acceptable level of service? At what point does level of service become impossible when you've got really high snowfall rates, and do you just say, "I'm sorry, we can't maintain our targeted level of service under these conditions"? So it's a very complex topic, and one that we really want to gain greater understanding into what level of service means and how the parameters that are modeled in MDSS relate to perceived level of service. Another area of potential investigation is the use of crowdsourced data or vehicle telematics. Crowdsourced meaning data that people report, and vehicle telematics meaning data that's reported by vehicles, for example, slip coefficients or uh, the fact that windshield wipers are operating, or any speed information from vehicles even could be an indicator of roadway condition. So how do we obtain that information? How do we ingest it? How do we interpret it in a way that is meaningful to directing our maintenance activities? Would be the area of investigation. And then the final one we have listed here is looking at the impacts of traffic um, on road condition. And this is kind of a complex thing too, because traffic affects road condition. Traffic can compact snow. It can sometimes help clear snow. Um, and it also works the other way, where the road condition affects the amount of traffic. When road conditions deteriorate, there's less traffic. So it's kind of a complex feedback loop where
Right.
each one affects the other, and understanding how the impact of traffic can impact the predicted condition of roadways would help us to do a better job of recommending future maintenance treatments. There are many benefits of participating in the pool fund study, and I would want to start out just saying that anyone who's any state that is interested in joining the pool fund study, we would welcome the conversation. It's not a closed group. We have had states join as recently as 2 years ago, and so um, the invitation is still wide open. It gives us a chance to collaboratively lead really advanced research and development on winter maintenance. Um, the work that we do is collaboratively directed. It's not that I decide what research we're going to do, or that DTN or Shawn decide what research we're going to do. The whole program is jointly conceived, jointly prioritized, and jointly overseen by the group. The pool fund study is a convenient way to fund research. The Federal Highway Administration has a mechanism in place where a portion of a state's federal aid gets transferred to the lead state. It's a very convenient and easy way to collaborate financially on important research. The MDSS pool fund study is also a low risk opportunity to deploy MDSS. So some of the states that have been in MDSS for a long time have actually moved to statewide deployment of MDSS. Every road segment on the state network is in the MDSS. Some of the more recent states are using this on a portion of their network to test it and to learn about it. But it's an easy way to do that without having to make a huge investment as an individual state in trying out MDSS and learning about it. A lot of learning happens within the pool fund study. And so there are three paths listed here. One is state to state. So one of the things that happens in every one of our meetings and in all of the work that goes on is just learning from each other. How are you using MDSS? What problems did you overcome? What other things are you doing in winter maintenance that relate to MDSS? And there's just a tremendous exchange of information, one state to another. Of course, we're learning from the work of our contractor. So the research that is happening is really the most advanced in winter maintenance. And we states are gaining the benefit of the scientific knowledge and experience that our contractor has and brings to the project. But I would also say that it's a two-way exchange, so that a lot of the intellectual property that we have developed, or I'll call it intellectual property, the knowledge that we have gained through the pool fund study has been provided from the states to direct the work of the contractor. And so this has not been a one-way exchange, it's been a two-way, three-way exchange where we're exchanging information from the states to the contractor, from the contractor to the states, and from the states to each other. The intellectual property that is embodied in the MDSS system is jointly owned by the contractor and the states. There is a formal IP agreement between South Dakota DOT and DTN governing the intellectual property. And that's an important thing because the states have invested in the development of the system. And the last thing I'd say is the MDSS is giving us a forum to really advance MDSS technology and kind of to have a voice in the evolution and the direction of maintenance decision support technology nationally. The picture shown here is a little bit out of date, but we've included it partly to pay homage to Leon Osborne. He's the fellow with his back to us in this picture, but he was originally at Meridian Environmental Technology and really was one of the visionaries who conceived some of the concepts of MDSS and led the project through many of its first years. And Leon's no longer with us, but we really owe a debt to the vision that he had for this technology. I guess I'd wrap up, Rick, by repeating that we would welcome any other state's interest in participating here. There's a lot to learn from each other, and every new state that has come into the pool fund study has brought new knowledge and insight that has been important to the evolution of the system and to its improvement.
Yeah, looking back, thinking back to that one of the first slides where you had the two different colors represented, and you mentioned that states can be using the MDSS without necessarily being part of the pooled fund study. What joining the study really does for you is give you a seat at that table to help with the development, the future development of functionality associated with the MDSS. Was that a fair assessment?
That's exactly true. because the what work is done in the pool fund study is determined by the membership of the pool fund study. The appearance and behavior of the MDSS system is heavily influenced by the MDSS sponsors. Almost well, I can say every meeting that we have, a good portion of the meeting is looking at features of the MDSS, potential improvements that could be made, new functionality that could be added, and so the whole direction of the development is is driven by the state needs.
Yeah, and as you mentioned, when I think back of where we were in in the phase one, phase two era of MDSS all those years ago, and think of the advancements that have taken place in computing horsepower, in modeling, in techniques and equipment, and that sort of thing. I don't think the MDSS actually will ever be done, right? I think there's that evolution is going to continue to move forward as technology moves forward, and as we get smarter about that whole traffic maintenance interaction, and the modeling and machine learning, and all of those things. I think that are just right on the horizon to that we can take advantage of.
I could jokingly say that it's job security for Shawn and me, but more to your point, winter maintenance is not a simple thing. It's a very complex topic, and you're right. I don't believe either that the system will ever be completely done because there'll be constantly new. Um, well, first of all, the topic is very complicated, so it's hard to say you've figured it all out. But but you're right with the increasing technology, and I would say the onboard technology on snowplows has been one of the key things. When we started MDSS, there really wasn't much onboard instrumentation. Now, um, the entire fleet of Minnesota and Nebraska and South Dakota are equipped with onboard equipment that report the road conditions, report what the materials have been applied, where the treatments have happened, when they've happened, um, and it's just adding new capability all the time, new power to what we're able to do.
Yep.
And interestingly, there's a lot of research in other areas from other groups like Clear Roads, Aurora, TRD, etc., that is very relevant to what we're doing. And we're looking forward to collaborating to gain information and bring that technology to be able to support some of these new ideas that are really going to move us forward.
So, Dave, Shawn, I really want to thank you for giving us this briefing on MDSS, a little bit of history, and what you've done and where you're going. I think there's a lot of exciting things happening in this world of decision support.
Thank you, Rick, for the chance to share this.
Thank you very much, Rick, for having us. Appreciate
Yeah,
it.
you bet. And uh, Dave, Shawn, your contact information is listed below this video, and we'll include it in the show notes along with the link to your website. And I would encourage folks to go out there and poke around a little bit and see what MDSS is all about, and reach out to Dave and Shawn if you have any questions whatsoever about the technology or the program, or how you might want to get involved. Until next time, thanks for tuning in and stay safe out there.